never, I will say this one is even never, right? Never try this. You can try it on your personal development, but on a production level, something that people will use, never try to fetch all the thing, then start using your normal code victory. So always use the where clause, right? So let's just quickly do that. For example, now instead of running this, to like fetch everything, if I'm actually working, right? Instead of running this to fetch everything, for example, I want to fetch a user with this email, right? So instead of running this to fetch everything and then using the array.filter, and better, I use the where clause and passing the email, where email equals to what, student one. And if I run this, it will automatically, it will like quickly, give me, it will filter it down and give me what I want. So the database is more optimized for filtering. So don't do the work of the database. That's just it. Allow it to do its work, right? Now the next point is DTO projection. So sorry I didn't show the Java code for DTO projection, but I believe we may have some knowledge on DTO projection, right? But I will try to explain it with regards to SQL, right? So that I don't have to show many screens. Yeah, so one good way to write efficient query is DTO projection, right? Which means, selecting only the columns you need, data transfer and usage. For example, if you only need email and student status, instead of fetching everything, just pick what you need. I need email, I need the student status, from the scoreboard where the email is this, right? So don't fetch the entire column, when you only need the email and the student status. So it is self-explanatory, so I don't have to like go to the DB to like run this for us, right? So don't do select all so you can use your query projection, on Spring Boot you use the select new, then the package, complete package name, package directory, then the class.
For example, if you only need
and you just select just what you need, right? So if you select the entire column, Hibernate have to hydrate that Java object. It has to hydrate that entity, right? And that entity may have like multiple joins. So you can see that performance is already degrading, right? So, but if you just go and you just pick what you need and performance is tripled. Like, try this if you don't use it, but I believe who all do it. There's no one that does this, but it is easy to do this, because when you do your normal Spring JPA find by ID, it is actually doing this because it will select everything about that user, right? So it is easier to to do this, and you mix up the entire system. While it may work in smaller apps, but as your system grows, it becomes terrible, right? So make a DTO. What do you need? What do you need? Right? I need email, I need ID, I need status. Just pick them from DB and go ahead. All right, so let's not overemphasize on that. The next part, which is very, very important, is indexing, right? So indexing makes our life easy way, in a great, though it's like a two-edged sword, right? So it makes query efficient by serving as a search shortcut for your database, right? So instead of running a full table scan, which is your sequential scan, it uses the index to jump straight to their record and retrieve it. So it leads to faster response time. Like how you have your book. For example, you bought The Richest Man in Babylon. The first page is like the index, right? If you want to maybe read about the law of money inside The Richest Man in Babylon, you just go to the index, it will tell you the page number. You go straight to that page number and you read it. So you don't have to start reading from page to page before you learn that the law of money. So that is how the indexing works. So just quickly, look into our lab on how to create index. So I've already prepared this query so that it will be fast, very, very fast for us, right? So to create your index, you just need to run a query, or like query or command, right? create index, the index name, then on the table you want and the column name. So let us say I want to create index on the email, right? Email column. I'll just run this and I'll run this and I've already created index, right? Good. I have a query here to just check the available indexes that I have, right? But sorry, before I create this index, I need to show you something. So before I create this index, let us see what performance looks like with that index, right? Let us see what performance looks like with that index. So if I run this explain, analyze, right? It's just like a query plan, right? If I run it, you see that we have, sequence scan. That means that we have a complete finding by email. The database engine will need to run through your entire record. Just imagine you have 10 million records. It has to run through it, right? So that shows that you're having sequence scan, right? Now, how does index, make this better? So if I now go ahead and I create my index on this, right? Let me create my index on this. And then I run this, query plan again. You can see that, it's now using index scan, and the execution time is quite reduced, from the 7 point something that it was before. So this is how indexing makes your query lookup very, very fast, right? But like I said earlier, indexing is like a two-edged sword. So you should only index, your frequently used columns, right? And two, for me, I would suggest that you don't index too early. Don't index too early. Index when your table is growing big, right? That's when you really need it, because index also has a way, of bringing down your write time, right? It affects it with more with more index you create. But we'll see that as time goes. So indexing strategies, right? So, just like every other thing in life, indexing requires. Can you hear me? Can you hear me, please, everyone? Hello, are we together?
Very well, very well. You are coming out.
All right. Thank you very much. Thank you. So just like every other endeavor in life, we apply strategies, right? So indexing requires the right strategy to deliver real performance benefits. Yeah. So without it, indexing can easily become an overhead with little to no gain. So in this discussion, I'll be focusing on 3 strategies for index. Though there are many strategies for indexing. I'll be focusing on 3
for index. So there are strategies for indexing.
I believe this for index. So there are filtered indexing or partial indexing. We don't really use them on a daily basis, but these 3 are like what we use on a daily basis. So that is why let's look into them. So single column indexing, like the first one that we created, the first index we created, you can see we created it on just one column. For example, create index, this IDS email on,
I didn't like this.
But column index, right? This works fine. It's really works fine. But when you start having you have maybe 2 or more filter criteria that you frequently use in your where clause, right? You can see that using single column indexing, for example. Okay, I'll still get to that. Okay, let me not run too fast. Yeah, so this works fine if you are filtering by maybe just one hot column each time, right? For example, I'm always filtering by email and nothing else, right? This works very, very fine, right? Now, it works until it's not recommended anymore. I'm not saying you should use it, but I say it works until a point where you shouldn't use it. There's a point you should use a different strategy. So let us see that point. Yeah, that is your composite indexing strategy. So for example, I will just go to the database directly so that I can quickly. So for example, now I have this query that selects by email and by student status. Let us say this is a frequent query, right? I'm always selecting by email, and sometimes I also select by student status, right? You can see that there's an extra condition here, right? Good. So instead of indexing email and student status differently, it will make a lot of sense to index them both together, right? Good. So now I can create what an index here on both of them. So if I create an index on both of them, yeah, but yeah, I can create an index on both of them, and if I run this query again to view my list of indexes, you can see that I have three indexes, right? One is from the primary key, which is the default, and the other one is from the index email and index email status. But now let us look into this critically. You have index email and you have index email status. Like you have two indexes. But this index, this composite index I just created on two columns. How it works is that if I'm filtering by email, it should work. And if I'm also filtering by email and student status, it should also work, right? So that means that I don't even need this first one I created. So that means that I should go ahead and drop it. I can drop this index here, quickly drop
it. It's like that video is coming out. The live streaming is coming,
right?
Audio
and if I run this query now, let me show you that it works.
Kind of
if I run and explain analyze
in tools,
analyze,
have you checked it out?
Lies on this, you can see that. Let me run quickly. You can see that we are still using index scan, right? Index scan is still being used when we filter by the two of those columns.
Okay.
And if I also filter by just one email, let us see if the index scanning also applies. You can also see that it still uses index scanning, right? So that means that your composite index, should be preferred, over your single column index, if you have more than one criteria. And mind you, like how you index it, email and student status, that is how it applies. So it applies when you just filter by only email and when you filter by both, right? So there's no point, now having to, yeah. So let's quickly go over, to the functional indexing. Sorry, I rushed over this. Composite indexing is indexing two or more columns, right? Instead of them separately. Now let's go into the functional indexing. Yeah, so this one solves a lot of problems, like critical problems, right? Now, for example, you have a table, right? A very large table, right? And the email column, that is emails, are not, uniformly cased. Some are having uppercase, some are having lowercase, and you don't have the option to normalize them. You cannot, bring this whole email to like same casing, right? Like it is a very large table, and you don't have the permission or the option to normalize them. So, you want to apply indexing, right? So instead of just creating a single column index on email and hoping that user will supply the correct cases, right? It is better to create functional index on email and convert user input to lowercase before filtering. Yeah. So I will show you a code example. Yeah. So for example, now, like I told you earlier, your email is not uniformly cased, right? So if you create like a normal, like your traditional indexing on email alone, right? Now, let us just see this query so that I don't speak too much on this. So let's see this query. So for example, now, that I index the email, right? I index the email. So if I do an explain analyze on this, let me just quickly copy the explain analyze so that I don't spend too much time writing. So if I quickly do an explain analyze here, you can see that here I'm passing a function, right? This lower function. So if I do, this stuff here, you can see that it is using a sequence scan, even though this email is already indexed, right? So if you have this situation, it is better you do a functional indexing. And how do you do a functional indexing? Simple. Same way you do your normal traditional indexing, simply come here, pass it as lower, since you want to use lower, right? Pass it as lower, and you can create your index on this, right? Just run create index, same thing, but use the lower function. So if I do this and I come back and I run this, let's see what we get. I see that we'll get like a bitmap index scan, which is not so optimized like your normal normal index scan, but it is on your sequence scan, right? There are ways you can make it better, but we'll not go into that, right? So we have seen the problem functional indexing subs, and not just lower and upper. Even date, want to use date function if you want to, once you want to do a function, right, and you want like a faster read, indexing gives you this faster read, right? I want a faster read. It's better I use functional indexing, right? So it solves your problem big time. Just quickly moving, avoiding performance killers. Yeah, be a quick one. So we have discussed how to optimize queries. In this session, we'll quickly look into a few SQL performance killers and how to avoid them. It is important to know that creating an index does not guarantee that it will be used. Like we need to pick this and note it down. Like for the fact that you created an index doesn't mean that the database engine is going to use it. The optimize or is it better I use your index scan? And the purpose of creating an index is for it to be used, right? So if you create an index and it's not being used, that means that there is something wrong with your query, even if it's running, but it's not good enough. And the optimizer have seen that your query is not good enough, so it will go back to sequential scan also, right? So we need to avoid that, right? So here we explore, how to increase the chances of the database engine actually being using our indexes. Please, can you all hear me? Hello?
Very well.
Now, let's quickly run through this. Yeah, so this one is very, very important, like very, very important. We need to, even if we don't gain anything from this class or this lesson, just need to get this. Creating index on a less cardinal column. For example, you have a student table, right? And there is ID, first name, last name, gender. I can see that gender, for example, in Nigeria here, right, we have basically two genders, male and female. So there's a possibility that everybody in your class will be male. Like I've been in a class where it is just 90% males and 10% female, right? So you can see that gender is less cardinal, right? So if you create an index on a less cardinal column, you won't get the benefit of indexing, right? Because the optimizer will see that most of the records are falling into this category. So there's no point of using index. It will do a full table scan for you. And also avoid creating indexing on booleans, right? Because it is true or false. There's no that thing that boolean can be true or false. So all the columns may end up being true or being false, So avoid creating index on a less cardinal columns, But if you must use, for example, your gender, if you must index your gender column, for example, now combine it with something that has a higher cardinality. For example, first name may have a higher cardinality, so you just need to create a composite index, right? Combine it so it increases the chance of that index being used. Yeah, the OR operator, I believe we all know this. If you have to, for example, you have select all from users where email equals number equals to this, and you have indexed your email and phone number. So using the OR operator, sometimes the DB engine may not efficiently use the index. So the solution is actually most times is to use the union operator. So because of time, I will not be demoing this because I'm almost out of time. So is to use the union operator. So this ensures that this part of the query is going to run on its own using the index you created, and this one will run on its own using the index you created, and it is way more optimized. So you can use the union, I can use the union OR, but the union OR is going to give you duplicates, if maybe there is duplicate, but the union will ensure that you don't have a duplicate. So it all comes down to what you want. Then the last one is, using functions on a non-functional index. Yeah, for example, you created index on email without lower or upper, right? And you end up using select all from users where, lower email equals to this. So automatically the database optimizer, will not use that index because what you created is a normal traditional index, not a functional index. Can you hear me? Hello?
Very
Hello?
well, very well, very well. You are coming out.
Okay, thank you very much. So if you must use functions in your where clause, check your indexing, check what you have, create a functional index, and that is it. Create a functional index if you must use a functional indexing, right? Then don't, you know, uh, interchange them. Yeah, so before I go to the last slide for always, indexing is not a one-off something. It is a simple app that can make your system very, very fast. You know that, right? But it's not a one-time of something. You just index and you go. You continuously re-index, you continuously check your query pattern. What has changed over time? What am I currently most often used? You re-index, you delete the old ones, and you bring in new one. That is how you make your system better. So it's not like a one-off something you get. So don't just index, once and you go, because once you index once and you leave it, you have many people working on that system. They may, change the queries, update the queries, and the filtering, criteria may have changed. So you have to always reevaluate, profile your queries, then go back and re-index, delete the old ones so you don't have many indexes. Always avoid too many indexes because it will affect the read. Yeah, so database query optimization is a vast topic, and we can talk about it for
Okay, apologies everyone. Good evening. I think he's battling with his network. So let's just bear with him. We all know how Nigerian network is really hectic. In the meantime, please let's keep our eyes on the chat. A new link will be dropped for the question and answering section. We'll be running out of time in the next 10 minutes, so we can join that link while we are waiting for him. Thank you. It will be dropping shortly.
Can you hear me? Hello?
Yeah, very well. You are coming out now.
Welcome.
Yeah,
Yeah,
welcome.
sorry, I lost my network. Sorry. Let me reshare my screen, please, so that we'll just quickly round up.
Okay, yeah, but we quickly shared because we are currently running out of time. I believe we
Okay.
have like 11 minutes. So a new link was dropped in the chat. I will drop it again now. So we could just join that new link so you can handle the question and answering
Okay.
section as well. Yeah.
Okay, thank you very
Thank
much.
you.
All right. So, Yeah, can you hear me? Hello? Okay, so we can take the questions, so that I don't take more time. My network has already, taken a big chunk of the time. Yeah. Hello?
Yeah, we can hear you. So anyone, if you have a question, you can raise your hand. Let's see. Okay. Any question? I think we fully understand. We fully understood the topic. That okay. Okay. Mr. Bright. Okay. Continue.
Okay, since Mr. Toshiko has, raised hand, then
Okay. Okay, Mr. Toshiko.
go ahead.
Mr. Toshiko, please.
All right. All right. First of all, Mr. Bright, I must say thank you for this wonderful presentation. And I just have a very simple question. I noticed your ID is using Syria. I wanted to know the reason for that, for using Syria.
Okay, that should be the ID type on the table, right? So that is, for serial number, like how you have it on your register 1, 2, 3, 4, 5, 6, serially, one following the other, right? So just for serial number, it's not like UID or just serially one, following the other, and also bigger than the other, on serial. It's why the first record is 0, next one is 1, next one is 2, next one is 3, next one is 4. That is just for logical arrangement. Yeah.
All right. But I noticed that this might also vary when you are using probably MySQL or you are using Postgres. Or what do you think?
No. It doesn't. If you are using Postgres, because what we actually use is a Postgres DB, but the provider is dbeaver, right? So it works same thing. Same query you have there is going to still work on your Postgres. Syria is just to one should follow the other, and one, the later one should be bigger than the former, right? Serially, like they say, arrange serially. You get. So 0, 1, 2, 3, 4, that in that order.
All right.
So it should
Thank
work
you. All right. I have two more questions.
Yeah, go ahead.
My second question is, why would you convince us now to use Beaver, since we are not that, probably for people that are not that familiar? Is there any special functionality you get from Beaver?
Okay, so there's no special functionality. It's good to try new things. Though I won't say the Beaver is new; it has been there for years, right? So it's just to take our mind away from the PG admin that we all know. We are already used to PG admin, so let me take our mind away from it a bit and try the Beaver. So just in case your PG admin is having issue, you can always switch to the Beaver. There's always second option. Yeah.
All right. My last question. How would you like, let's assume you are using raw SQL now in your application, and when you are migrating, maybe probably you are migrating your DB and you have a native queries in your applications, like as you recommend, right, using queries for some operations, and you have a lot of native queries in your application, and probably you want to migrate databases. How will you handle that situation?
Okay, so I take your question that you have, like, so for example, a Java EE application that has already used normal native SQL, and they want to migrate it to Spring Boot. So how will you do that, right? Is that your question?
Yeah, my question is probably maybe you are using MySQL initially,
Mhm.
and probably you want to switch to Oracle DB and you want to switch
Mhm.
to Postgres DB, and most of the times their native queries differs. There are some
Yeah, yeah. Mhm.
there are some stuffs that might actually differ from a particular query you run in MySQL would have some issues running in Postgres, but still the same native queries. But there are some different.
Yeah,
So
I
in a
get
situation
it.
whereby you have a lot of that in your application, probably a large scale application, how do you go
Yeah.
about managing it? Yes.
Yeah, great. Like, I would say this, right? Uh, we have, different flavors of SQ, like you have mentioned, but most times they are internally they are same select, right? Good, good. So, but if you have, really used, for example, maybe Oracle specific queries, and you are moving to maybe Postgres, then at that point you just need to look into updating that. You can maybe move it to JPQL, right? JPQL is, platform agnostic. It doesn't know SQL, it doesn't know pgadmin. So you can maybe try to update that Oracle specific query into JPQL. That works, right? Yeah, so it is almost similar to your query, but it's just that, okay, you are bringing in some, Java objects, Spring Boot assisted something, right? So I don't know if that answers your question.
Thank you, Mr. Bright. That answers my question and I really appreciate. But though I still have a concern, what's the downtime of using JPQL over native queries?
Okay, so for me, I will say this: there is no downtime. Like, there is nothing, unless if you didn't write your JPQL well, right? JPQL, you're kind of using some Java objects, to fetch, right? But unless if you didn't write it well, and you still have that same problem in SQL if you didn't write your SQL well. So JPQL and your native query, they work very well, provided that you write any of them well, right? So what I won't advise someone to use is using the normal data GPA, those follow come repository, queries and stuff. But if it is JPQL, writing your normal JPQL queries, it will always work any day, anytime, very, very fast, whether you optimize it well. And same thing happens in SQL if you don't optimize it well.
Okay. Thank
Yeah.
you.
All right, Mr.
Thank
Bright.
you
That
very much,
answer
Mr.
my
Toshiku. Mr. Innocent, you have a question. Please, you can go ahead with your question.
Okay. Good evening from Nigeria, everyone.
Good evening,
Good evening.
Innocent.
Okay, so I have one question, but before I ask the question, I want to add some things to some of the questions that Tochko asked in the previous session. So, based on the question about the benefits of using the Beaver, basically, one thing with the Beaver share is that it's not tied to any particular database management system, right? Just like pgadmin is tied to Postgres and Workbench is tied to MySQL. So with the Beaver, you can connect any database. You can use it to connect to any database, right? So that's one of the benefits. So when you have the Beaver and you have Postgres server and MySQL server and even some other database server, right? You can use it to connect to them. So that's one of the major advantage of the Beaver. And I think it's lightweight too. And then on the second question, on the other question that you asked about if you have a native query in your application and you want to maybe migrate to another database, I think to honor the contract of one of the principles of Java, that's open and close. So you can, instead of modifying your query, I think one way you can do that is maybe you can have an interface where you can have all your method for database operations, right? And then you can have some implementations So let's say you are using an Oracle SQL, you can have an Oracle implementation of that SQL, right? And then have all your Oracle database queries there. Then if you want to, let's say you want to use MySQL tomorrow, you can now have your MySQL implementation. Then you can configure JDBC templates with that MySQL, basically. So that way you can still switch between different database clients. So that's one way to maybe solve that issue without tampering with already working code. Yeah.
Okay.
All right. If I might give a follow-up question on that, I think what you just said is very clear, but I might have a follow-up question in the case whereby you are using probably a database migration tool. Would there be any effect on those changes? Like, let's assume you are using something like Flyway or Lookybase in your application.
I think it will what? So if you're using a migration tool, so let's say you want to use it to migrate to another database. So your that means your code, your native code is not within your code now, right? It will be in the migration tool, like you read it from maybe an SQL file in your migration tool. I don't know if that is correct.
Yeah, you're right.
So I think it will be easier to change it from, like, you're not modifying the code. You just you use your migration tool and then change the SQL syntax for that client that you want to migrate to. Good. That's just a simple answer to that. Maybe there might be some nuances that you might want to consider in that case scenario. Okay, so that's just my 1 cent I wanted to add. So my question to Mr. Bright, thank you for your session. Though I did not join early, but I don't know if you covered maybe some of the drawbacks that comes with indexing when you are using indexing on the application. So I don't know if you want to throw more light on it.
Yeah, like indexes in your system, indexing is more on the reading side, right? It kind of favors read over write, right? So when you have too many indexes, it affects the write, number one, and also for every time you update or you create a new record, your index is always re-indexed. So that is another computation power that is being used. Okay, and also index takes space, right? There are queries to check, okay, what is the size of this index? And you can see that sometimes if you run, you can see that it's running in 2 megabytes or sometimes in 2 kilobytes, and it takes space. So while there are good things, it also comes with some other drawbacks. But finding a balance is everything. You need to balance it, but there's always trade-offs in everything. Yeah. So do you get that?
Yeah, sure.
All right.
Just to add to it, just to avoid most of this, just only index what's it called, like frequently accessed columns. Like if you check your application and you know that some of the fields are like there are some fields that are frequently queried for, right? You can then index that. Don't just index because you feel that this column needs to be indexed and then just index it. Just look at your application and check the frequently accessed column, and then you can index it to avoid some of the overhead that comes with. Not avoid, but to limit some of the overhead that comes with index. Thank you, Bright, for that succinct answer.
All right.
Okay. Thank you, Mr. Innocent. Thank you, Bright. Thank you to Shuku for your questions and the response and the contributions. So I don't know if anybody else has a question. I have a question, but I think they have been answered from the contributions and questions asked. I wanted to say something about the beaver. I don't know if the beaver is only because I've used it, but I wasn't. I was able to generate the schematics. There is the diagram of an already existing DB with dbeaver, and I'm not sure I could achieve that with PHP admin. Please, you can correct me if I'm wrong. So I think that's dbeaver has more features for me, that because I use it in fact that's our go-to tool in where I work at. So yeah, dbeaver has more flexibility, and also that if you want to like get an overview, a larger overview of what you can get the I say the pictorial, the schematics of your DB. It will give you that in a PDF form. You get that will give you a very good understanding of what is happening, what your DB structure is. You get so I believe you can do that with PHP or any of these tools, but I think you can also do that pretty easily with dbeaver also. So be that as it may, I think. Oh, thank you very much for the correction. I didn't know. I haven't tried it with PG admin. Thank you very much, Israel. So Gloria will be taking. I think she was having network issue. That's why I had to take up from here. So Gloria, you can have the floor.
For making this section a success. And firstly, I want to thank Mr. Bright for the impactful section. Thank you. And if you want us to be doing this every Tuesday, I want you to react with your favorite emoji. Your favorite emoji. Favorite emoji. Some persons are not reacting. It's just as reacting. Okay. All right. So we'll be meeting same time. Thank you. We'll be meeting same venue by this time next week, Tuesday. But before I call it a day, there is someone in our midst. He is my mentor. He is my SA. He is my advisor. He is my father. He is no other person than Mr. Innocent. I want to invite him to give us more like an opening talk or an encouragement as a junior developer out there struggling. Thank you. Mr. Innocent, you're welcome.
I must see set it up. Guys, I beg, please don't take whatever Gloria is saying today to her. Like, sometimes she can be exaggerating. Good evening. I don't know. I'm not expecting this. So, nothing much. I'm still learning, and all of us are still learning, and trying to find our feet in the software Java ecosystem and software development world in general. So I urge us to keep on learning. This career is a career of constant learning, constant pushing yourself. Anytime you stop learning, you stop growing, and anytime you stop growing, the industry will pass you by. That's just the truth. There's no way you can say that you've known it all. The more you are learning, the more you find out that there's more to learn, and the more you keep on going. I see a lot to learn, but the good thing is, if you get your basics right, you will definitely excel. So I urge us to don't just rush. Make sure you get your core Java, your basics, your core Java and basic SQL. If you know your basic SQL and then your core Java, I believe you can be able to scale whatever role. You just need a little research and then a little more context in order to be able to do other more advanced topics. So that's just a little peace from my mind. And please, I'm still a learner too, and all of us are learning, and that's why I'm here, to learn from some of us. Thank you, guys.
Thank you very much for that wonderful speech. Guys, we'll be holding him for one of our sections. So at this point, we're going to call we're going to call it a day. Keep on subscribing to our channels and keep your eyes on the. Oh, Tochiko has something to say. Oh, sorry. Please, the floor is open for you.
Yeah, I really have nothing much to say than to say thank you to Mr. Bright. This is a very, very wonderful section. And the reason why I most appreciate him is that what he just gave out, it took him time to actually grasp this thing. So giving it out in a second doesn't mean it's that easy. Honestly, I know how it is. So, Sir Bright, I really appreciate this section. I really appreciate it. Thank you very much for giving to the community. I really appreciate it. What I wanted to observe is if there's anyone here who has probably a reservation or something to say before we wrap up. It might not be a question, maybe contribution or something like that. I think that's all. That's all from me. Well, Miss Glory, if nothing like that, then you can go ahead and wrap it up.
All right. So thank you very much, Bright. I really appreciate and we appreciate as well. Thank you for your time. And then, like I mentioned earlier, you can just keep your eyes on the LinkedIn or the WhatsApp group or the YouTube channel for the upcoming section. The details will be dropped probably either Saturday or Sunday. So thank you all for joining. And at this point, we'll just call it a night. Good night, everyone, and do have a lovely sleep ahead.
Good night,
Thank you.
everyone. Good night, everyone. Please, you guys should fill the form. We need speakers.